Welcome to The Explainer. So today we're tackling a question that has probably crossed the mind of, well, almost every single homeowner at some point. Just picture this. It's 6 a.m., the house is freezing, you stumble out of bed, drag yourself into the bathroom, and you just want a hot shower. But instead, boom, you're met with this blast of ice-cold water. It really makes you wonder, doesn't it? Are hot water recirculating pumps actually worth it? Today, we're pulling our insights directly from the plumbing and HVAC experts at Smart Housing Systems. We're going to break down exactly what these systems do, when they genuinely make sense, and this is absolutely crucial, the hidden costs you really need to know about before you even think about calling a plumber. I mean, we've all been there, right? You turn on the shower handle and then you just wait. You stand there shivering on the cold bathroom tile, kind of testing the water with your hand every 5 seconds. Meanwhile, gallons of perfectly good, perfectly clean water are just pouring straight down the drain. It's a completely universal, visceral annoyance. Actually, to put that into perspective, over the course of a single year, an average household can send thousands of gallons of treated water directly into the sewer, literally just waiting for it to warm up. It feels incredibly wasteful because, well, it is wasteful. It wastes your precious morning time and pumps up your monthly water bill. But the big question is throwing a motorized piece of mechanical equipment at the problem actually the right solution for your specific home? So let's dive right into part 1, the cold water problem and understanding the delay. Okay, let's get into the nitty-gritty. Here's the foundational definition we're working with today. A hot water recirculating pump is basically a system that promises faster hot water at your tap by continuously moving water through your plumbing. But to really grasp why this is even a thing, you kind of have to look at why that delay happens in the first place. So, under normal circumstances, your standard copper or PEX pipes are often completely uninsulated, and they're routed through really cold spaces. Think inside unheated walls, crawl spaces, or even buried right there in concrete slabs. When you turn off a hot water tap, the hot water that's sitting in those pipes, it just sits there. And because the surrounding environment is cold, it sucks the heat right out of that standing water in a matter of minutes, dropping it right back down to room temperature. So the next time you turn the tap on, all that cooled off water literally has to be pushed entirely out of the pipes before the fresh heated water from your water heater can finally reach you. What this recirculating technology does is keep that water constantly moving. It loops it back to the heater, bringing the heat right to the fixture so it's ready the exact second you turn the handle. Pretty clever, right? So, when does installing one of these pumps actually pay off? Well, instead of just reading a list, I want you to think of these points as a personal diagnostic checklist for your own home. First up, do you routinely find yourself waiting a really long time for hot water? This usually happens because your specific plumbing layout naturally creates massive delays. Just picture a sprawling, larger home where the water heater is tucked way, way back in a basement corner, and your master bathroom or primary kitchen sink is located on the complete opposite end of the house, maybe even upstairs. The sheer physical distance that water has to travel means you are going to spend a lot of time waiting for that temperature to rise. Secondly, these systems are just incredibly attractive for households that have super consistent morning and evening routines. If your hot water demand is highly predictable, say everyone in the family gets up for work or school and you're all showering between 6 and 7:30 a.m. without fail, these systems can be dialed in perfectly. They can deliver near-instant hot water exactly when you need it, which drastically cuts down on the water you'd otherwise be wasting while waiting. But there's always a catch, isn't there? Let's move on to section 2, the catch. Looking at energy trade-offs and the price of convenience. Now, looking at the ultimate balancing act of this technology, you can start to see why it really requires some careful thought. Let's start with the good stuff, the pros. You get way less waiting for hot water, which, let's be honest, is a massive quality of life upgrade. You also experience far fewer of those annoying temperature swings. You know, when someone flushes a toilet or turns on a dishwasher, and you either get scalded or frozen. And crucially, you send a lot less wasted water down the drain, which is great for conserving a really vital resource. But look at the cons weighing the other side down. You are absolutely going to see increased energy use. Why? Well, because even if the pump only runs intermittently, the very act of moving that water introduces continuous heat loss through the piping. Your poor water heater has to work so much harder to maintain the temperature of the water that is constantly circulating out into those cold pipes and back again. Plus, you've got to factor in the upfront cost of the pump itself, which can run a few $100s, not to mention potential long-term maintenance. You're looking at periodic checks, scale buildup, maybe even sensor adjustments down the road. Ultimately, you're constantly weighing your daily comfort against those ongoing operational costs. So this brings us to an absolutely crucial point, and it's a hard rule. Any recirculation plan must be paired with sensible insulation of your hot water lines. Think about it for a second. You're intentionally moving hot water through the pipes all throughout your house just to keep them warm. If those pipes are bare, they essentially act like giant radiators inside your walls or basement, just bleeding all that expensive heat away into empty air. The financial impact of this can be completely staggering. Without proper insulation, your water heater is going to be running constantly just to replace that lost heat, utterly destroying the overall efficiency of your system and leading to some seriously skyrocketing gas or electric bills. The experts at Smart Housing Systems are crystal clear on this. If you're going to install a pump, you absolutely must insulate the lines. It is totally non-negotiable. Okay, moving right along to Section 3, Demand versus Timed Systems, the System Showdown. If you've looked at the pros and cons and decided, yep, it's worth it for my home, you now have to choose exactly how the system is going to operate. Homeowners generally have two broad categories of solutions here. Looking first at demand-based systems. These activate using a motion sensor or some kind of manual signal, like literally pushing a physical button next to the bathroom sink, right when you need the hot water. The pump kicks on, does its job of bringing the hot water right to the fixture, and then immediately stops. This setup is absolutely ideal if your household's hot water usage is, well, kind of chaotic, sporadic, or totally unpredictable throughout the day. It only recirculates when you actually call for it, which severely minimizes energy waste. Contrast that with timer-based systems. These are programmed to run continuously during specific, preset time windows. Now, if your family has highly predictable, super consistent schedules, like everybody wakes up and showers at the exact same time every single weekday before rushing out the door, this works brilliantly. You'll never even have to press a button. The hot water will just be waiting for you. But if your actual demand doesn't match the programming, say on a lazy weekend when everyone sleeps in, a timer-based system is going to end up wasting a massive amount of energy pumping hot water when literally nobody is awake to use it. So you really have to match the technology to your actual lifestyle. And this brilliantly brings us to our final section, Section 4. Is it worth it? The Homeowners Diagnostic Test. We've broken all of this down into a really handy 4-step diagnostic checklist based on the source material, and I want you to really take a moment to think about these steps for your own home. Step 1, actually measure your practical wait time. Don't just guess. Seriously, tomorrow morning, go to your most used fixtures, the kitchen sink, the master shower, turn the hot water on, pull out your phone and start a stopwatch. If the wait is consistently long, the value of getting a pump goes up significantly. Step 2, consider your plumbing length and layout complexity. Where exactly is your water heater in relation to those main bathrooms? Longer pipe runs and really complex routing mean more wait time and much more potential heat loss. Step 3, evaluate your operating pattern. Are you a highly regimented household with super rigid schedules, or is your usage completely unpredictable with folks maybe working different shifts? Remember, this dictates whether you need a time system or a demand system. And finally, step 4, look at your efficiency controls and absolutely prioritize that pipe insulation we talked about earlier. Actually, if your pipes are easily accessible right now, say in an unfinished basement or a crawl space, insulating them really might be step 1. Doing just that might solve enough of your problem before you even need to think about buying a pump. So, ultimately, our final recommendation really comes down to treating recirculation as a highly targeted improvement. Please do not just buy a pump blindly because you're annoyed on a Tuesday morning. Measure your real-world wait time to confirm you have a genuine problem that actually needs fixing. Choose a control strategy, timed or demand, that actually matches how your family lives on a day-to-day basis. And above all, prioritize insulating those pipes to reduce that massive heat loss. As the experts note, this specific combination of factors is exactly what determines whether a recirculating pump becomes a fantastic convenience upgrade that you absolutely love, or just a frustrating, ongoing energy expense that spikes your utility bills every month. So I'm going to leave you with this thought the next time you're standing on that freezing cold bathroom tile just waiting for the shower to warm up. Take a really critical look at your own plumbing layout. Is your home truly ready for the mechanical investment of a recirculating pump? Or could you honestly solve half the problem right now just by taking a quick trip to the hardware store and adding better insulation to the pipes you already have? Measure your wait time, evaluate your layout, and make the smart, efficient upgrade for your home. Thank you so much for joining me on this explainer, and hey, happy learning!